Two important areas in the life cycle of a product are design and manufacturing. Process planning serves as an integration link between design and manufacturing. Process planning consists of preparing a set of instructions that describe how to fabricate a part or build an assembly which will satisfy engineering design specifications. So let us now discuss the process planning in detail. It involves describing detailed instructions that one uses to fabricate a part to specifications. The instructions include operation sequences or the processes, the tooling and fixtures to be used, inspection methods to be used, gauges to be used, and the graphical representations, etc. Process planning is an act of preparing a detailed processing documentation for the manufacture of a piece part or an assembly. Involves a number of activities. First is part print analysis, which is called as analysis of part requirement. Selection of the raw work part, that means the basic shape and size of the work pieces. Determining manufacturing operations and their sequences. Selection of machine tools. Selection of tools, work holding devices and inspection equipment. Determining machining conditions and manufacturing time. What is this analysis of part requirements? The part requirements can be defined as part features, process that includes the process determination steps of processes. Dimensions, it will take decisions regarding the selection of machine tool size. Tolerance specifications, the capability of machine tools can be selected based upon the tolerance specifications, and the CNC code generations, etc. And selection of raw workpiece. It involves such attributes as basic shape of the workpiece. You can have standard materials, whether it is a rod or a slab or a blank or a profile, and the dimensions, pre-shaped, sometimes pre-shaped materials, cast parts, forged parts, extruded parts, like that. Size of the workpiece, basic raw material, and size of the machine tool, size on which this workpiece is capable of holding it, and material conditions, tool selections, other things. Determining manufacturing options and their sequences. Selection of the processes like availability, accuracy of requirement, suitability and cost. Sequence of operations. There are several operations. What operation is to be done first? What operation is to be done next? Work holding methods. How best you have to work hold the methods so that maximum number of processes can be done on the given workpiece without change of setup. Cutting tools availability, cost of the cutting tools. You can do the operation with the least cost tools, and you can do the operations with the more costlier tools also. So all these things depends upon the process planner how he select it, and in which very important thing is selection of machine tools. Workpiece related attributes like part features and dimensions, dimensional tolerances, raw materials form. Machine tool related attributes, which includes process capability, size of the machine, mode of operation, manual, semi-automatic or automatic, CNC, if it is a CNC machine, parts. These are all already available, and this data is very much required for the process planner. Then the selection of tools, work holding devices and inspection equipment. Tools, we have to select based upon the tool material, shape, size, nose radius, tolerances of work holding devices. The primary purpose of a work holding device is to position the workpiece accurately and hold it securely. Manually operated devices, they are collets, chucks, mandrel, faceplates. Design devices, power chucks, specially designed fixtures and jigs. Flexible fixtures used in flexible manufacturing systems like pallets and other things. inspection equipment, online inspection equipment, and offline inspection equipment. And the planner also selects the cutting conditions and the manufacturing times. That is machining conditions. Machining conditions includes what is the cutting speed, what is the cutting feed, what is the depth of the cut you will select for one typical operation. So object is to set the cutting conditions in such a way that the economically best production state is achieved. Choice of cutting speeds, you can select high speed or low speed. High speed will give you low tool life, high tool cost, high production rate, shorter production time. Low speed, high tool life, low tool cost, low production rate, long production time. Manual or experience-based process planning method. Even today it is popularly used. Second one is computer aided process planning method. Let us discuss these things. Manually method or experience-based process planning method. This method is most widely used method, but it's time consuming because it is completely depends upon the human planner and his knowledge and his experience. Its use is still very widely spread in small to medium sized companies, especially in the aerospace industry. It involves subjective judgments reflecting the personal preferences and experiences. Plans prepared by different planners for similar parts are usually not identical. Very labor intensive, like 40% of task, involves preparation of documentation. Process planning activities in a schematic way is like this: analyze the part requirements, determine operation sequence, and select the equipment, and calculate processing time. And this is an iterative procedure. Calculate processing time. If this is more or less, again select new equipment like that, and decide the equipment, and then document the process plan and communicate the process plan to the shop floor people. Factors affecting the process planning activity are volume of production, the skills and expertise of manpower, delivery dates, the schedules, material specifications, accuracy and process capabilities of machines, accuracy requirements of parts and products. Because of these variations, we need to go for automating the process planning activity. Can we do the process planning activity computerized or computer augmented process planning activity? Yes, it is. It is required to develop computer aided process planning or automatic process planning in order to have consistency in process plans and to reduce redundancy in process plans, to reduce time of preparation of process plans. We need to go for automated process planning activity. Particularly in the age of computer integrated manufacturing, we don't have any other option except to computer aided process plan in order to link the computer aided design and computer aided manufacturing departments. Process planning provides the link between CAD and CAM. Process planning function converts engineering designs into fabrication instructions. Thus, automated process planning is key to integrate CAD/CAM. Of course, the computer integrated manufacturing. Certain potential benefits of the automated process planning, which includes 50% increase in process planning productivity, 40% increase in capacity of existing equipment, 25% reduction in setup cost, 12% reduction in tooling, 10% reduction in scrap and rework, 10% reduction in shop floor labor, 6% reduction in work in process, 4% reduction in materials. Other benefits include process rationalization and standardization. CAP leads to more logical and consistent process plans, lower manufacturing cost and higher quality. Increased productivity of process planners, more work to be accomplished. Reduced lead time for process planning. Shorter lead times, manufacturability, feedback, lowering the production cost, consistent CAP, computer aided process planning, how to achieve. There are two varieties. CAP can be done in two ways, or two approaches are there. One is called as retrieval or variant computer aided process planning system. The other one is called as generative computer aided process planning system. Sometimes the two systems combine and known as semi-generative computer aided process planning. Let us see what is this variant process planning approach. This variant process planning approach is a group technology based approach. It is based on group technology and process PCC, dependent on good data mining and search engines. Variant CAP system requires a database containing standard process plans. A standard process plan is stored in computer files for each part code. The standards are based on current part routines in use in the factory or an ideal plan prepared for each family. System has provisions for editing a particular standard plan to accommodate product variation. In a nutshell, the entire schema of the retrieval CAP system or variant CAP system is presented here, in which a new part design for which we need to develop the process code. For that, first of all, when the part design comes, we need to derive the GT code, group technology code, and against the group technology code, search for the part family file containing the GT code. So we need to have a part family file in which the GT code is searched. Retrieve if the plan is existing, the same GT code, you retrieve that, or retrieve the nearest code. That means nearest part process plan of a part is to be retrieved, and do the editing operation, edit the existing plan or write the new plan, so which is easy because only few features are different. So edit the process plan and develop a new process plan and put them in the order, and the process plan format prepare the other application programs. So part family file is required, standard process plan file is required, and the coding system is required, and preparation of standard process plans for part families is also required. So these are all in order to develop a CAP system. These are the preparatory stages like selecting code system and prepare standard process plans for the part families. Suppose you are going to develop a variant system which is suitable for few part family. For all those part family parts, you need to develop the GT codes and their respective process plans and store them. This is a preparatory kind of study. You have to do it before you start working for the new part program, new process. In order to develop the process plan for a new part, you need to do these preparatory. Let us discuss the advantages of retrieval CAP system. Once the standard plan has been written, a variety of parts can be planned. Comparatively, simple programming and installation is required to implement a planning system. Efficient processing and evaluation of complicated activities and decisions, thus reducing time and labor requirement. Standardized procedures by structuring manufacturing knowledge of process planners to company needs. Lower development and hardware costs, shorter development times. Disadvantage of variant process planning system. Maintaining consistency in editing is difficult. It is difficult to adequately accommodate various combinations of material, geometry, size, precision, quality, alternate process sequences, machine loading, etc. The quality of final process plan generated depends on, to a large extent, on the knowledge and the experience of the process planner. Now let us discuss the generative computer-aided process planning system. An automated computerized system is used to generate each individual process plan automatically without reference to planning is still continuing. The structure of a generative process planning is like this. Let us say start or a new part, component representation module. you can develop the component representation, that means input to this by means of the geometry means CAD. You can use the computer aided design details, which consists of geometrical details, or sometimes you can give the part geometry creation also. You can create in a user defined way, you can create the geometrical details and give it as an input to this. And if it is an old part, copy existing part or geometry file to the geometric file and do editing, and the editing module is there. And once that is over, the operation extraction is done by the sequencing module. And operation extraction, intermediate process, dimension computation, and operation sequencing. These operation sequencing algorithms are required here, which gives you prioritize the operations and sequence their operations. And selection of the machine tool is to be done. Machine tool selection module is available. So a huge database of machines tools availability and machinability conditions that are available on the shop floor must be available in the form of a database, and the database will be interacted with this module, and the necessary data will be extracted from the database. Standard time and cost computation module, we have to have a library of standard times for all the things in order to calculate the machining times, cost calculations, etc. And then report generation module, editing, modification and printing, and the process plan is ready. Components of the generative computer aided process planning consists of description, component characteristics, geometric features, dimensions, tolerances, and surface conditions. A subsystem to define machine parameters. A subsystem to select and sequence individual operations. A database of available machines and tooling. A report generator. Let us just discuss the generative CAD system in the form of steps. First step is input engineering specifications into the CAD system. That is part features which can be given like geometrical features, tolerances, sizes, locations, etc. Sometimes their coded information is stored as raw data in computer. Also describe the part in its rough state. It should be given as input. Ideally, engineering specifications should be captured directly from CAD file, and the current research is also that the CAD file is given as a direct input to the CAP module, and CAD file, the input may be in the form of .dxf files or PDES files or step files. The information is to be given as input to the CAP module. Step 2. Generate programs to transform coded data and textual information into a detailed process plan.